Hello everyone. Today again we are going to discuss the continued part of the chapter wave optics in this session 6. So in this session today we are going to discuss regarding the constructive and destructive interference. So for that we have to consider the two waves of same frequency with different amplitudes A1 and A2 superimposing at a point, then the displacement of the both the waves that will be given by y1 is equal to a1 sin omega t and y2 is equal to a2 sin omega t in plus delta, where omega is our angular frequency and delta is the phase difference between the first and the second wave. So according to the principle of superposition, the resultant wave displacement that will be given by y is equal to, it is y1 plus y2. So y1 is equal to our a1 sin omega t plus y2 is a2 sin omega t plus delta. Therefore y is equal to, we can write it as it is a1 sin omega t plus it is in the form of sin of a plus b form. So sin of a plus b means it is sin a into cos b plus cos a into sin b. Therefore expand this term, that is a2 sin omega t into cos delta plus a2 cos omega t into sin delta. Therefore our equation becomes y is equal to, so take down sin omega t is common. So therefore in the first term left out is a1 plus it is a2 cos delta. Therefore sin omega t is common plus a2 cos omega t into sin delta is the left out term. Now we are going to substitute in the above equation, that is a1 plus a2 cos delta as r cos theta and a2 sin delta. a2 sin delta we will substitute it as an r sin theta. Therefore our equation becomes now, that is y is equal to r sin omega t into cos theta plus r cos omega t into sin theta. Therefore we can write it as r is taken common. Therefore y is equal to r of sin omega t into cos theta plus cos omega t into sin theta. Now again it is in the form of sin a plus b, that is sin a into cos b plus cos a into sin b form. Therefore y is equal to, we can write it as r of r into sin of omega t plus theta. So the above equation, which will be represents the simple harmonic vibration of amplitude r and the angular frequency omega. Now the squaring and adding equation 1 and 2. So our equation 1 and 2, just you observe here, that is equation 1 is r cos theta, that is equal to, it is a1 plus a2 cos delta, and similarly equation 2 is r sin theta, that equal to a2 sin delta. So first you have to squaring and add these terms. So left hand side squaring we can write it as it is r square cos square theta plus r square sin square theta, this equal to the right hand side, it is a1 plus a2 cos delta the whole square plus a2 sin delta the whole square. Already we know r square is taken common. Now it is cos square theta plus sin square theta. So this must be equal to the right hand side, the first term it is in the form of a plus b the whole square form. Therefore expand this, it is a1 square plus a2 square cos square delta plus 2a1 a2 cos delta. Similarly the next term it is plus a2 square into sin square delta. Already we know cos square delta plus sin square cos square theta plus sin square theta is equal to 1. Therefore our left hand side it will be given by, it is r square. So r square is equal to a1 square. Similarly here a2 square cos square delta, here a2 square sin square delta is there. Again cos square delta sin square delta is equal to, it is 1. Therefore we can write it as it is a2 square plus it is 2a1 a2 cos delta. Therefore our again equation can be written as it is in the form of the resultant amplitude r, that r is equal to under root a1 square plus a2 square plus 2a1 a2 cos delta. So the phase angle, that theta, that will be given by, again the tan theta is equal to r sin theta divided by r cos theta, that equal to a2 sin delta whole divided by a1 plus a2 cos delta. So next we are going to discuss regarding the constructive So what is the conditions for constructive interference? So in this case, the constructive interference, the amplitude is maximum and hence the intensity is also maximum. So for that we can write it as now R is equal to our resultant amplitude already we got now, it is A1 square plus A2 square plus 2A1 A2 cos delta. The resultant amplitude R is maximum. When it is maximum means when our cos delta is equal to plus 1. That is delta is equal to, it is 2n pi, where n is equal to 0, 1, 2, 3 so on. Thus, R will be maximum when the phase difference between the two waves that will be given by the delta is equal to 0, 2 pi, 4 pi, 6 pi so on. That is even multiple of pi. If the delta is the path difference between the waves corresponding to the phase difference delta, then the delta is equal to 2 pi divided by lambda into the path difference. This is the formula for the phase difference as well as the path difference. So phase difference delta is equal to 2 pi divided by the lambda wavelength, and the delta is the path difference. Or the same equation we can write it for the path difference, that is delta is equal to lambda divided by 2 pi into the delta. Therefore, substitute the value for delta. The delta is equal to, already we know it is a 2n pi. Therefore, delta is equal to lambda divided by 2 pi as it is, and our delta, whenever the resultant amplitude is maximum, this is the case for only 2n pi. So we have substituted, it is 2n pi. So 2 get cancels. Similarly, our pi is also get cancels. Therefore, our delta is equal to, we can write it as it is n lambda. Or the same equation we can write it as delta is equal to 2n into lambda by 2. Again 2 get cancels, we are getting it as n lambda itself. Either we can write it as n lambda or it is 2n into lambda by 2. Therefore, for constructive interference, the phase difference between the light waves must be equal to even multiple of pi. So if it is a constructive interference, then the phase difference between the two waves must be equal to, it is a even multiple of pi, or the path difference of the waves must be equal to the even multiple of lambda by 2. Either the phase difference must be even multiple of pi, or the path difference must be the even multiple of lambda by 2, where lambda is the wavelength of the light. Then the maximum amplitude that will be given by R maximum is equal to, it is A1 square plus A2 square plus 2A1 A2 as it is, because cos delta is 1 already we know for maximum. Therefore, it is in the form of A plus B the whole square form. However, it is in under root. Therefore, we are getting it as an A1 plus A2 itself. And similarly, the intensity is also maximum. That intensity, maximum intensity, we can write it as that maximum intensity which is directly proportional to the square of the amplitude. So square of the amplitude is, now it is A1 plus A2 the whole square. Therefore, now we can consider if A1 is equal to A2 is equal to A, both the amplitudes are same, then our resultant amplitude, that maximum amplitude R maximum, that will be given by, it is 2A. However, it is A1 plus A2. So A1 is equal to A and A2 is equal to A. Then we can write it as A plus A. Therefore, R maximum is equal to 2A. Then the maximum intensity I maximum, which is directly proportional to the square of the amplitude. So square of the amplitude is our 2A we got. Therefore, it is square of the amplitude is 4A square. So this is for the constructive interference. Similarly, we can study regarding what are the conditions for destructive interference. So when there is a destructive interference, already we know the amplitude is minimum and hence the intensity is also minimum. So for that, again the equation R is equal to under root, it is A1 square plus A2 square plus 2A1 A2 cos delta. So if R is minimum, when it is minimum means it is cos delta is equal to minus 1. So when this cos delta is minus 1, that is delta is equal to, it is 2n plus 1 pi, where n is equal to 0, 1, 2, 3 so on. Thus, R will be minimum when the phase difference between the two waves that will be given by delta is equal to pi, 3 pi, 5 pi, 7 pi, so on. That is odd multiple of pi. And if delta is the path difference between the waves corresponding to the phase difference delta, therefore we can write again by the relation delta is equal to 2 pi by lambda into delta, or delta is equal to lambda by 2 pi into delta. Again substitute the value for that. Therefore delta is equal to lambda by 2 pi. Our delta will be the minimum for this value is 2n plus 1 pi. That value we have substituted. So pi get cancels. We are getting that delta is equal to, in this case, is 2n plus 1 lambda by 2. Now for destructive interference, here the phase difference between the two light waves must be equal to the odd multiple of pi, or the path difference must be equal to the odd multiple of lambda by 2, where lambda is the wavelength of light. This is very important. You have to remember, for constructive interference it is an even multiple of pi, and for destructive interference it is odd multiple of pi, as well as the path difference is odd multiple of lambda by 2. And the minimum amplitude that will be given by R minimum is equal to, it is a square root of a1 square plus a2 square minus of 2a1 a2. Why it is minus means, here cos delta we have taken it as minus 1. Therefore it is in the form of a minus b the whole square. Therefore under root is there, it is a1 minus a2. Similarly, the minimum intensity that will be given by I minimum, that minimum intensity which is directly proportional to the square of the amplitude, that is a1 minus a2 the whole square. If a1 is equal to a2 is equal to a, then it is a1 minus a2 is equal to 0. Therefore our R minimum is also 0, and similarly I minimum is also equal to 0. So this is what regarding what are the conditions for constructive as well as the destructive interference. This is a very important. So thank you for this.